I am writing the first and second equation we derived in the last times. So it is xy is equal to yx times this was our first equation. मुझे दिखना चाहिए थोड़ा सा पेपर पे. Okay. So there are 6 faces of any cube, just as we studied in the last lecture. There are 6 faces of the any cube, and the force acting on each face are 3 times direct force and 2 shear force in the x and y, x, y and z direction. So this we have studied in the last lecture. And out of the 3 force on each force, 18 forces, there is these shear force are equal. We proved already in the last lecture. And the strain in the x direction is del u by del x, y direction del v by del y, and z direction it is del w, where u, v and w are the displacement in the x, y and z direction. So unit displacement is called the strain. Okay. Now let us come to further Hooke's law. As you already studied that if you applied a force on any bar or something, so in the direction of the applied force there is some elongation or compression depending upon the type of force, it is tensile force or compression. But apart from that direction, other direction is also affected. So the force create in the one direction, it creates the elongation or this strain affect the body in the other direction also. So as we studied in the 10th, 11th, 12th, the Hooke's law, the strain in the due to the force in the x direction, and if 3 forces are applied, then the strain in the x direction is means sigma x is the force applied on the all the 3 forces are applied, but for strain in the x direction is due to the sigma x and also due to the sigma y and sigma z. Though the sigma y and sigma z are not acting in the x direction, but still they create the distortion in the x direction also. So this is the Poisson's ratio. This is the Poisson's ratio, and in the applied force the elongation or contraction is the positive, and other direction it is negative. Similarly, can you write the EY? You please, anybody open your mic and tell me the formula for EY and EZ. Anybody? No? It is very simple. It is just the rotation. X, you put the Y, you put the Z, put the X. Here, Y, Z, then X, then Y. It is like this. So this is your third equation. You write the number of equation properly. Whenever we'll go in the future, I will ask you use the equation number 3. So you will be able to use the equation number 3. ओहो, ये तो सूख रहा है. अब क्या करेंगे? थोड़ा गीला करना है क्या इसको? थोड़ा गीला करें इसको क्या? कोना सूख रहा है पर ये तो देखो.
मैं कर देता हूँ.
अरे कब तक करोगे आप? मेरा तो सब्जेक्ट ही है.
देखिए थोड़ा ये जो मार्क है ना पुराने हो गए, वो कुछ पुराने हैं कुछ नए हैं, तो एकदम क्लियर है.
Have you written the third one? Anybody respond me? Have you written the equation third? This thing, so I can remove. क्या हुआ? आवाज का क्या हो रहा है? Anybody attending the class or just putting the mobile?
सर क्लास में तो है पर मतलब बाकी का पता नहीं सर. मुझे आवाज नहीं आ रही आपकी.
Oh my God.
क्या आ रही है?
आपका नेटवर्क देखिए. देन विवेक कौन है? विवेक पाठक. विवेक पाठक.
सर आवाज मुझे भी नहीं आ रही, आपकी कम आ रही है.
जी सर.
बोर्ड पे दिख रहा है लेकिन.
अच्छा जी जी सर.
बोर्ड पे दिख रहा है सर.
हाँ.
वो उसका सेल चेंज कर तो
एक मिनट सर, सेल चेंज कर रहे हैं.
कभी बाई चांस.
हेलो, अभी आया क्या आवाज? अभी मेरा आवाज आया क्लियर थोड़ा?
नो सर.
कट के आ रही है आवाज सर.
ओ माय गॉड, कट के क्या आ रही है? ओके. चलिए, बोर्ड तो दिख रहा है. आपकी मुझे आ रही है ना?
बोर्ड पे दिख.
हाँ. अब ये मैं ये रिमूव कर दूं. आपने नोट कर लिया?
हाँ सर.
ओके. इक्वेशन नंबर 3. एक जना मुझे रिस्पांस करते रहे, कोई भी एक, है ना? तो मुझे ठीक रहता है फिर. यार यहाँ तो दिक्कत जाएगी थोड़ी, मेरे को लगता है. उधर कोई आया है क्या? नेक्स्ट टाइम फिर से, क्योंकि ये मिटाना बड़ा मुश्किल है यहाँ. Yes, okay. Now, now you write. Now consider the case of deformation of rectangular. Consider the case of deformation of rectangular parallelepiped. PARALLE piped, applied with the tension force. We take the two-dimension case. On the upper and lower face, it is subjected to tensile force, and on the other side, it is subjected to compressive force. Sigma Z, sigma Y. Now, in our this subject, the forces are per unit length or per unit area. So, if there is a length, then all the forces are the per unit length. So, any force you want to find out the complete, you multiply by the length of that side and the stress, means the total force will come. Now, cutting out an element ABCD parallel to the Z plane, okay, and the 45 degree. So, this angle is the 45 degree. Now, normal forces on the perpendicular BC are 0. Normal forces on the perpendicular BC are 0 and parallel forces are the shearing force. Now, if we take one force as a positive, then it is another will be the negative. Any you can change the thing, any you can take the positive, because one is tensile force and one is the compressive. So you just change the sign. So if the forces are equal, then sigma z is equal to sigma, if we consider, and sigma y is equal to minus sigma, like this. Okay. Now, this condition is called the pure shear, because the shear force is acting on the this ABCD. Now, elongation, you write something. You in between, yes.
Sigma z equals to
Sigma, both the sigma. We are taking the case of the same force is applied. So we are taking, yes, very good. You respond me, I like it. So you write down the something. This condition is called the pure shear. Elongation of OB is equal to the shortening of the OC. O is the point here somewhere. Elongation of the OB is equal to the shortening of the OC. Length AB and BC of the element do not change. Length AB and BC of the element do not change during deformation. Angle between sides AB and BC changes. Angle between sides AB and BC changes. Now you can draw this one triangle. C O B sigma Z sigma Y and the shearing force tau. Do you know the resolution of the forces? You might knowing the resolution of, we resolve the forces if we want to find out some force. So if want to find the force, shear force, we resolve this force into the same direction and this force in the same direction of the tau. So as I told you, to find out the complete force, tau is multiplied by the length BC is equal to sigma y sin 45, because the resolution is in the this direction is multiplied by the length. Here, which length you multiply? For the sigma y? Sigma y acting on which length?
Sir, OB?
OB, yes. You multiply the length OB to find out the total force. Now, This is in the one direction and these two are in the same direction. So again for the sigma z you multiply by the OC. OC into sigma z cos 45. If you send the BC here, then OB by BC sigma sin 45, how much? Value of sin 45. Value of sin 45 is sin 45 value 1 upon root 2 it is very basic. And what about the cos? Cos 45 is again 1 upon root 2. Now anybody can tell me in this triangle OB upon BC is what? Sin cos 10. OB upon BC. If the angle is this, OB upon BC in this triangle, sin cos 10. The side opposite the angle is called, what is called, and which makes the angle is called base, hypotenuse and perpendicular. There are three sides. Pradeep Rathod, Mr. Pradeep Rathod, open your mic. आज हमारे रेगुलर वाले बच्चे क्यों नहीं आए क्या पता. So this is OB upon BC is the perpendicular upon the hypotenuse means sin 45. OC upon BC is the cos 45. Again this is 1 upon root 2 sigma into 1 upon root 2. 1 upon root 2 sigma into 1 upon root 2. If you multiply 1 upon root 2, 1 upon, it is 1 upon 2 sigma plus 1 upon 2 sigma. 1 upon 2 sigma plus sigma is equal to 1 upon 2 into 2 sigma. 2 cancel, tau is equal to sigma. बोर्ड तो नहीं गिर जाएगा
ये नहीं गिरेगा
क्योंकि ज़्यादा प्रेशर लग रहा है ना. Yes. Now, after deformation, what happened? This direction, it was the tensile force, so it is like this. 45 means pi by 4. If there is a small change in the angle, so OC upon OB, OC upon OB ten pi by 4 minus lambda 1, and it is 1 plus EY upon 1 plus EZ. If you took the unit length, so after deformation, this is 1 plus EY and this side become 1 plus EZ. If you will not respond me in the online classes, I will call you offline. Can you hear me?
सर हम वो क्लास में हैं सर, मतलब वो आवाज कट कर इस कारण से हम समझ नहीं पा रहे हैं।
कोई बात नहीं, ये आपकी आवाज आ रही है तो मुझे रिस्पांस करते रहिए। कौन बोल रहा है? ये दुर्गेश ही बोल रहा है, बाकी तो कोई बोल ही नहीं रहा है। प्रदीप राठौड़ इज नॉट देयर आई थिंक, एंड विवेक इज आल्सो।
आपकी वॉइस नहीं आ रही सर, वॉइस ब्रेक हो रही सर, कुछ समझ नहीं आ रहा है।
अरे यार क्या करें भाई, उधर चलें क्या है?
सर क्लास में ही हूँ मैं, विवेक।
ओके, विवेक भी है। तो मुझे आपकी आ रही है ना, पर आपको बिल्कुल नहीं आ रही क्या?
सर आ रही है पर वो
ओके ओके,
ज्यादा ध्यान से सुनना पड़ रहा है, समझ में नहीं आ रहा है मतलब क्या।
अच्छा अच्छा अच्छा, ओके। तो ये दिखा आपको, आफ्टर डिफॉर्मेशन देर इज ए द साइड्स, मैंने बोला कि दोनों सेम रहेगी ओसी, है ना? देर इज ए चेंज इन द एंगल एंड मीन्स आफ्टर दिस इज स्ट्रेन. So unit, if you take the unit length, then the strain is 1 plus EY upon, and in this triangle it is OC upon OB is the tan theta. So it is 10 pi by 4 minus lambda upon 2. Can you solve this? Tan A minus tan B. Do you know the formula for tan A minus tan B? Tan A minus tan B. Angle tan A minus B angle. What is the formula? We already studied in the 10th class, I think. Anybody? It is tan A minus tan B divided by 1 plus
1 plus 10A into 10B.
Yes, very good. This is the formula. So we'll apply this formula. Now we want to find out the EZ and EY. So EZ. Equation number 3. Do you have? From equation 3, we already, you have the equation. You tell me. Yes, like this. So EZ is 1 upon E sigma Z minus Poisson's ratio sigma x. In this case, the sigma x is 0. Sigma x is 0. So EY is equal to 1 upon sigma Z minus V sigma y. I written here one is positive and one is negative. So sigma Z is equal to sigma and sigma y is equal to minus. Put the value sigma minus v minus sigma, it becomes 1 upon e, sigma common, 1 plus v. Similarly, this is the sigma z. This is similarly it is minus 1 upon e sigma y, 1 plus v. This is the, now you put the value here, put the value of Ez and Ey here and solve this also. So as we wrote the formula 10a minus 10b, here 10a minus 10b 1 plus 10a 10b is equal to put the value of this stresses 1. So this is 1 minus 1 plus v upon e sigma divided by 1 plus v divided by e into sigma. If you will take the LCM, so this becomes e minus 1 plus v sigma divided by e, this is plus 1 plus v sigma, means e is cancelled, it will cancel in the denominator and the numerator. So you will get these things. And if you solve, can you tell me the value of 10 pi by 4 or 1045? 1045. What is the value of 10 pi by 4 or 1045? It is 1.
1.
Yes. If the angle is very, very small, because we are unable to see the deformation with the naked eyes, it is just a very, very small. So in the case of the theta is very small, so tan theta is very, very, very small. So value of tan theta is equal to for the value of theta very, very, very small, tan theta is equal to theta. So here it is lambda upon 2 and this. Now this equal to E minus 1 plus V. This thing I am writing here. E you cross multiply and give me the solution for the this you call, what is you call this, alpha beta gamma, what you call this? You solve this equation. This is nothing to do with the M.Tech. This is a simple equation. Anybody can solve. The 11th boy also can solve this equation. Here if you take the LCM, then 2 minus lambda upon 2 plus this is gamma. So 2 will again cancel like this. Now you cross multiply the things. You will get 2e minus 2 1 plus Poisson's ratio into sigma minus 1 plus Poisson's ratio sigma two e 2 1 plus v into sigma, this 1 plus v is into this is equal to 2e minus plus 2 1 plus v.
सर ये जो लिख रहे हैं इधर दिख नहीं रहा है.
अच्छा, अभी क्यों सर, पूरा बोर्ड दिख रहा है क्या? अभी दिखा होगा मेरे ख्याल से. हेलो.
हाँ सर.
ओके
हाँ सर.
ओके थैंक यू. यू राइट डाउन दिस. इफ यू कंप्लीट यू टेल मी, आई विल.
यस सर.
एनीथिंग इज कैंसलिंग. Anything is cancelled.
सर लास्ट में जो इक्वल टू के बाद का 2e माइनस गामा e प्लस 2 ब्रैकेट में 1 प्लस v.
This one 2e minus gamma e plus 2 1 plus Poisson's ratio sigma minus bracket 1 plus Poisson's ratio sigma into what you call this? Alpha, beta, gamma, or what is this? What is this symbol?
सर गामा.
Gamma. Okay. If it is gamma. Now, anything is cutting in these two equation? Okay. Again, if you solve this, then you will get this I send here. So 2 plus 2 4 this, and that I take here. So it is this one. This becomes positive if it comes. So this one and this one becomes 2, and these 2 and these 2 becomes 4. Okay. This is called the shearing strain. This is shearing strain. So this is equal to 2 से 2 2 जा this 2 1 plus Poisson's ratio sigma upon E. This is equation number 4. As we proved in the previous notes, the sigma is equal to tau. We already proved in the previous notes, you can see. So you replace this by tau. So shearing strain is equal to shearing stress divided by E, or you can write, if you write this as a G, if G is equal to E upon 2 1 plus V. This is equation 5. Put the value here, so you will get this is equal to tau upon G. As in the normal case, strain equal to shear force upon E. In the normal case, strain equal to direct force upon E, modulus ratio. In the strain, it is shearing strain is equal to shear stress divided by the G. G is called the modulus of rigidity. Modulus of rigidity. Modulus of rigidity. I am observing that only one person is taking the interest, others are sleeping. If you are doing the M.Tech, I will not permit you to sleep in the class. Mr. Pradeep and Mr. Vivek.
सर वॉइस क्लियर नहीं समझ आ रहा सर.
This is not the reason, because the other person is also hearing me, na? So you can give the response at least.
Yes, sir.
The board is clear. The voice has no means it is only 20% is, but on the board it is 80% you are seeing on the board. So you give me the response. I am asking you what is the value of tan 45, what is the sin 45. Nobody is telling. So how you will do the M.Tech? You are doing the master degree in the structures. You will design the bridges and multi-story building and all those things. If you don't know the little things, then how it is? It requires your signature for any design in the future. So how will you sign? Okay, so the equation 1, 2, 3, 4, 5. Everybody has? You give me the one by one. All of having the equation 1 to 5. You go back in your notes. Yes, Pradeep, Mr. Pradeep, 5 equation you have. Pradeep. Then Durgesh.
Sir.
5 equation you have in your notebook. 5 equation 1 to 5.
Yes, sir.
Any problem? If no, you go through your previous notes also. So 1, 2, today also yes. No. Today I wrote the equation 1 and 2 of the previous class. So all the equation I explain you today also. 1, 2, 3, 4, 5.
Yes, sir.
Then Vivek.
Yes, sir.
You have 5 equations? You check it. Okay. If shearing stresses are acting on the side, all the sides of the element, then for this equation number 5 you can write with the different direction. So you can write the xy is equal to tau xy upon g, yz is equal to tau z y, sorry, here it is y, yz upon g and gamma, zx is equal to tau zx upon g. This is the equation number 6. We generalize this equation 5. Strain is equal to stress upon modulus of rigidity. E is called the modulus of this, and this is called the modulus of the rigidity, elastic modulus. Okay. Now elongation 3 and 6 are independent of each other. Okay. Now take the general case. Take the general case of strain produced by the 3 shearing components, 3 normal and 3 shearing component stress. Okay. Now consider the case of strain produced by the normal stresses and the shearing stresses. Okay. Now we are going to derive the formula which comes in the exam of the 12 numbers. Okay. So be careful. It requires the practice. You write down your rough notes and prepare the fair one with the reasons, and I will require your fair copy as an assignment to give the sessionals. So be careful about the notes. आज उधर यदि कोई नहीं होगा फ्राइडे को तो फिर उधर से ही लेंगे क्लास. आवाज का भी इशू आ रहा है नहीं. Yes. So let us take the case when the forces are acting in the 3 dimension. Then strain, if we call the strain is equal to Ex plus Ey and Ez, and theta stress is equal to sigma x plus sigma y plus sigma z, like this. Total strain and total stress. If we denote total stress by theta, sigma x plus sigma y plus sigma z, and total strain E is equal to Ex epsilon x, epsilon y and epsilon z. These are called the equation 7. And we are going to prove the equation 8.
सर ये दिख नहीं रहा है
दिख तो रहा है
सर यहाँ से
अच्छा मुझे यहाँ दिख रहा है बोर्ड पे जो डिस्प्ले आ रहा है उस पर मेरा जो ये डिस्प्ले मुझे टीवी पे दिख रहा है
हाँ अब ठीक ठीक हो गया सर आ रहा है
ओके we are going to prove the equation number 8, the relation between the total strain and total stress. Total strain and total stress, we are going to prove the equation number 8 with the help of previous equations and this equation number 7. Okay, now in this equation you put the value of Ex from equation 3. Now you tell me what is the value of Ex, the epsilon x from equation 3. Equation number 3, if you have, you tell anybody. From equation 3, you are not the KG boys or first class, you are the student of M.Tech. So this will not do. You have to do something. You are not always take the ready-mades. I am just asking equation 3 we just wrote today. What is the equation number 3? I already told you.
X minus
This is
sigma y plus sigma z.
yes, simple. If you put the value of these things in this, again like this, you put the value. ये क्या हो रहा है? You put the value of these things.
Yes sir.
Keep the 1 upon E common overall. And if you write this inside, this thing, this thing, this thing. This is, and this is. This we took the common. Understood? We are just putting total strain is equal to strain x direction, strain in the y direction, strain in the z direction, and we are putting the value from equation 3 ex, ey and ez. You are getting this. Take the 1 upon e common, so inside you will get this plus this plus this, and if this is multiply, this is 2 times, you will get everything. 2 sigma s, 2 sigma. Take the 2 common and Poisson's ratio common, you will get this thing. Understood or not?
Sir, yes sir.
Okay.
Yes, sir.
Okay. Now we can take the sigma x, sigma y and sigma z is common. So here it is 1 and here it is 2 Poisson's ratio. We are going through this equation. E is equal to, started from this here. Can you put the value of this is equal to theta? So theta upon E 1 minus 2E. E is equal to, this is equation number 8, I think. It derived. Equation 8 is derived. Have you written? Should I rub?
सर
Yes.
ये सर कैसे तो बता सकते हैं कैसे?
हाँ बताइए.
ये जो इक्वेशन अपन ने कॉमन लिया है यहाँ पर ये सेकंड लास्ट स्टेप में,
हाँ यहाँ
उसके बाद मेरे को समझ में आई इसके जस्ट ऊपर ये वाला
ये यहाँ हाँ ये अंदर ब्रैकेट में पहले ये था, इसकी स्टेप यहाँ लिखी है मैंने. नेक्स्ट स्टेप तो ये हो गया अभी.
जी
सिग्मा एक्स सिग्मा वाई ब्रैकेट में, और दिस इज 2 कॉमन लिया, v इंटू 2 सिग्मा एक्स सिग्मा वाई सिग्मा जेड, ये कॉमन लिया मैंने यहाँ अंदर से. दिस आई टुक द कॉमन, दिस एंड दिस, सो इनसाइड हियर इट इज 1 एंड हियर इट इज 2 Poisson's ratio. Okay. Then I put the value of this as a theta, because from here we know all the stresses, summation of all the stresses is equal to theta. So theta upon E 1 minus 2E is the equation number 8. Now should I rub?
Okay sir.
Okay. Now consider the case of uniform hydrostatic pressure. You understood the hydrostatic pressure? Anybody? Hydrostatic pressure. If something is merged in the liquid, some liquid, whatever it is, it may be water, it may be oil. Yes, it may be water, it may be oil, it may be anything liquid. So in that case, the force applied on the body from all the sides is equal if it is submerged in the water.
Yes, sir. Pascal's law, sir.
Yes. So in that case, sigma x is equal to sigma y is equal to sigma z is equal to minus p. Generally we took the compressive force as a negative because it compressed the things, reduce, and the tensile force it elongs, so it will take the positive. So now put the value in the equation 8, so you will get 1 minus 2 Poisson's ratio upon E, and theta is equal to minus 3p. Theta is equal to sigma x, sigma y plus sigma z minus p plus minus p is equal to minus 3p. So this is the case. 3 1 minus 2v. This is the case of the uniform hydrostatic pressure is act on the this thing, and E upon 3 1 minus 2v is called the modulus of volume expansion. Modulus of volume expansion. We are expansion because we are talking about the volume. The whole the body is subjected to force, equal force, and we are talking about the volume. Yes. Now the next equation, which I told you, it comes in the exam of 12 number question out of 60. 5 question you have to solve in the exam. One of them is this solution equation we are going to derive. Yes. In the previous notes, equation number 3. Again I am repeating that all the equation will use in the future. So tell me equation number 3. Anybody? Equation number 3. Equation 3, all are sleeping? Should I close my class? Stop the class? आवाज जा रहा है कि नहीं उनको?
जा रहा है.
All students are sleeping?
No, sir.
Okay. Then equation 3, you complete this equation 3. You attend the yesterday also, I think, Pradeep.
Yes, sir.
So you complete this, you tell me what is the next equation 3.
Sir, mu sigma y plus sigma z.
Yes. Good. If we'll take the interest, it will good. Now we know theta is equal to sigma x plus sigma y plus sigma z. So put the value of sigma y plus sigma z. Theta minus sigma x is equal to be sigma y plus sigma z. So you put the value of sigma y plus sigma z from here. So you will get sigma x minus Poisson's ratio theta minus sigma x. Now equation 8 just we proved. What is the equation 8? From that you tell me the value of theta. From equation 8, anybody? What is the value of theta from equation number 8? First tell me the equation number 8. Yes, Durgesh.
Sir, equation 8 theta by e upon theta by e into 1 minus 2.
No. Here what is E is? E is equal to 1 minus 2 Poisson's ratio divided by E. Theta. This was the equation 8.
Yes, sir.
Then from where value of theta? You give me the value of theta from here. Very simple.
1 minus 2 में.
Okay. Value of theta, you send E here and this here. So you,
Yes, sir.
yes. Now put the value of theta here. Now before putting the value, you write expression for sigma x. Here only. From here I skip one. This is the first, this is second, and this is third step. So from here you write down the expression for the sigma x. You send this here. It will be E epsilon x plus V theta minus sigma x. Put the value of now theta. Open the bracket. Now take the sigma x on one side. So you will get sigma x plus sigma x Poisson's ratio is equal to आ रहा है समझ में?
Yes, sir.
Good. If you revise the things today only, then it will be better to for understood the things. Otherwise, after 2-3 days, everything will gone. So you please make the fair notes today only. Okay. If you take sigma x common, 1 plus Poisson's ratio is equal to this. Now for the sigma x, if you send 1 plus Poisson's ratio with another side, so you will get Ex upon 1 plus Poisson's ratio plus E upon 1 minus 2 Poisson's ratio. If lambda is equal to VE upon Poisson's ratio upon 1 plus V 1 minus 2V. We are sending 1 plus V from Poisson's ratio there, so it will come in this also and this denominator also. Put the value of this as a lambda. So you will get and put the value of G. What is the G? Two 1 plus V equal to G. From equation 5. From equation 5 we know that G is equal to E upon 2 1 plus V. So it comes 2 G E X. This is the equation A. Similarly, you can write sigma y is equal to lambda E 2 G E y, sigma z is equal to lambda E 2 G E z. So these three equations are equation number 11 and it generally asked in the question paper. The equation number 11 is generally asked in the papers to prove. So if you study carefully, you can derive this equation. आया क्या समझ में? समझ में आया क्या? एक तो चला ही गया.
Yes, sir.
कोई डिफिकल्टी हो तो you may come to the college and you can ask me if you have any difficulty. पेपर कहाँ गया? Okay. So let me finish the class as I post in the your group my classes in Monday on and Friday at 9:45. बंद कर दिया ना। अटेंडेंस डाल दो यार, कौन आए थे। आवाज का क्या है?
हेलो
यस।
सर बहुत सारे लोग ज्वाइन नहीं कर पा रहे हैं
अच्छा।
क्लास।
ओ हो। तो जब आप कर पा रहे हो तो वो क्यों नहीं कर पा रहे?
क्लिक कर रहे हैं तो कनेक्ट नहीं हो पा रहा है।
अरे अरे अरे, चलो कुछ करेंगे नेक्स्ट टाइम भाई। सुन रहे हैं आप? ज्वाइन नहीं कर पा रहे, बट somebody is joining and somebody is not unable to join. What is this? प्रदीप राठौर।
तो सर वॉइस का भी सर
हाँ इशू आ रहा है। ओके ओके ओके।
बिल्कुल भी कुछ समझ नहीं पा रहे थे।
यस, सही सही बात है। ठीक है ठीक है। लास्ट तक नहीं समझ पा रहे थे? हाँ,
सर
अभी तक नहीं समझ पा रहे थे? कुछ ठीक हुआ कि नहीं हुआ?
मतलब वो तो जैसे आप बोर्ड पे लिख रहे थे उससे हम लोग गौर करके देख रहे तो समझ रहे हैं कि आप क्या बता रहे हैं।
हाँ,
ऐसे बहुत दिक्कत आ रही सुनने में कि
हाँ।
क्या बोल दिया करके।
अच्छा।
हम लोगों को पूछते भी है ना सर, तो हम लोगों को समझने में बहुत देर लगती है आपने क्या पूछा करके, फिर हम रिस्पॉन्ड करते हैं।
तो कल तुम लोग ऑफलाइन आए थे क्या दुर्गेश?
वॉइस का इशू आ रहा है ना सर, इसलिए समझ नहीं पा रहे सर वॉइस।
हाँ हाँ, तो यार आज ऑनलाइन क्यों हो गए? तुमने बोला था मैं तो रोज आएंगे हम लोग।
जी 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 सर, आने वाले थे सर, मैं बाहर चला गया इसके लिए नहीं आ पाया ऑफलाइन।
हाँ अगर आओगे तो ज़्यादा अच्छा है। आई विल लाइक।
जी जी सर।
यस सर।
और ज़्यादा समझ में आएगा, ये वॉइस वाइस सब लफड़े ख़त्म हो जाएंगे। मैं तो वेट कर रहा था तुम लोगों का कि मैं समझा कौन कौन था। तो 2 जने थे क्या कल?
जी सर।
अभी 2 जने कल थे क्या कि कल कौन था? एक ही थे तुम? विवेक भी था क्या कल? विवेक पाठक भी था क्या कल? कल कौन थे 2?
हाँ
नहीं, कल कौन कौन आए?